So we'll look at another example for accelerometers. So again, here a machine is subject to the vibration. So this is our base. Okay, so one grammatical error here should be n. N accelerometers with this one and with that one. So basically, the specifications, okay, is used and to estimate. So we want to find the accuracy. So accuracy, that means we simply want to get the ratio of these numbers and then see how much percentage the perfect value is equal to 100%. Right? Okay, so we still with that equation, starting from that equation, again, our goal is to find out the ratio of these numbers, which means we simply calculate what is this number here. Okay. So we plug in information. The first one is determine R. So here we have two parameters, R and zeta, to be determined. What is R? R is the working frequency, the ratio of the frequencies. Omega is the working frequency, and what is that? The machine is subject to the base excitation. This is omega. Omega equal to 50. Okay, and divided by omega n. What is omega n? We are given here 100. So this number should be very straightforward. Okay, and then so here we determine R. How to determine zeta? The zeta is determined by this. We are given omega d equal to this. So omega n equal to that. So you know omega d equal to omega n multiplied with 1 zeta squared. So using this equation, omega d equal to 80, omega n equal to 100 times 1 minus zeta squared. So from here you can determine zeta. Okay, and the calculated zeta is 0.6. So you have zeta, you have R, you plug in here, then you can calculate this ratio. That ratio represents is the percentage of measured respect to the actual one. So that done the problem here. Good? Okay, so that's it.